Okay, so we had the square root of 12 plus the square root of 18 minus the square root of 27 minus 8. Okay, so looking at this question, we don't have any like terms. It's a 12, 18, 27, 8, so they're all different. So as they stand, we cannot add or subtract them. Okay, so what we want to look for or to look to see is if we can reduce any of them. Okay, so the square root of 12, can we simplify it or reduce it? Well, yes, we can. We learned in the previous example that 12 breaks down into square root of 4 and the square root of 3. So we're going to break down the square root into the square root of 4 times the square root of 3. Okay, now we're going to do for each of them, see if we can find a simplified version of each. So the square root of 18, again, if you divide by 2, you'll get 9. So 9 is a nice number to square root. So square root of 9 times the square root of 2. Okay, continue. Now it's 27. Can be broken down to the square root of 9 times the square root of 3. That's 9 times 3 is 27. And lastly, 8 is 4, square root of 4 times the square root of 2. Okay, so square root of 4 times square root of 3 plus square root of 9 times square root of 2 minus square root of 9 plus times square root of 3 minus the square root of 4 times the square root of 2. Okay, now we're going to simplify each one that can be square rooted. So 4 square roots to 2, carry down the root 3. The 9, square root of 9 is 3, carry down the root 2. Again, square root of 9 again is 3, carry down the root. And lastly, the square root of 4 is 2, and carry down the other radical. Okay, so now if we look at it, we do have like terms. We have the root of 3 here and here, and then we have the square root of 2 here and here. Okay, so 2 root 3 minus 3 root 3 is negative 1 root 3. You don't have to write the negative 1. Then 3 root 2 minus 2 root 2 is 1 root 2, or just root 2. And if you put the ones here, you can. You don't have to. Okay, it says you don't have to write the ones. All right, moving on to the last question here. Last question says to change the mixed radicals into entire radicals. So we're going to go the other way now. Okay, so we're going to go from a mixed radical into an entire radical. So what we do is we square this number here. So if we square 25, you get 25. Okay, but now you put it underneath of a radical sign. So we're going the opposite way. So 5 is the same thing as the square root of 25 times root 3. Carry that down. Okay, now we're multiplying. Just multiply the numbers under the radical sign, and we get the square root of 75. Okay, and the last question here, negative 2 root 5. And we're going to square the number, leave the negative where it is. Oh, by the way, when we're doing all these here, we didn't take into account any negative numbers. So when we square root it, it's just going to be positive numbers. Okay, so when we break all these down, so the square root of 4, positive 2. Square root of 9, positive 3. So we're not doing negative values. So here, we're just going to carry down the negative sign, because assuming that this was turned into a negative since the sign's negative. So we do 2 squared gives you 4. So we have 2 squared is the root of 4. So the square root of 4 is the same as 2. And then carry down the root 5. Now multiply these together. Carry down the negative once again. 4 times 5 is 20. And that's it. Okay, so the homework is there on the lesson. So it's page 167, numbers 1 through 7. But when you're doing the work for that pages, I want you to alternate the letters. So for 167, so 1 second. So for instance, question 1 has A, B, C, D. So I just want you to do A and C. But number 5 has A, B, C, D, E, F. So I want you to do A, C, and E for that one. Okay, so number 1 to 7, alternate the letters for all of those. And then 9, 10, 12. Let me see. 9, 10, 12, and 15AC. I'll just write it here just in case. Page 167, numbers 1 to 7. But you're alternating letters for this one. So ACE or AC. Then 9, 10, 12, 15, AC. All right. Take care, guys. Bye.